So this one says two fair tetrahedral dies. All right, faces numbered 1, 2, 3, 4 are rolled. It says they're rolled. The numbers obtained on the turned down faces are noted. All right, no problem. All right. Create a sample space listing all possible outcomes for the two dice. There are two dice. So basically, how we're going to do this, we're going to have, all right, it's like we have, oh, I'm going to write this up now. Let us say I have for dice 2 or die 1, anyone. Say if I have die 1 up here, and if I have die 2 at the side. We're going to try to look at the idea, all right? For example, we could have number 1 coming, number 2 coming, number 3 coming, or number 4. We don't have any more than that. Those are the possible things. So I'm going to just draw some lines, go down. Those are the 4 things that we can get because it's a tetrahedron and they did say, right? But it's going to be the same thing for die 2. We can get a number 1, we can get a number 2, we can get a number 3, or we can get a number 4. So I'm trying to build the possible outcomes, right? So if I throw the dice, what will happen? That's what we're checking on right now. When I throw these dice, what's going to happen? What are the possible things that can occur? So we don't know to say that this will happen, but these are the only things that can happen that we're going to be listing. So what we want to list here is, so let us say that you have a 1. A 1 and 1 die could show with a 1. So I'm lining it up so that we could do it systematically. So a 1 and die 2 could go with a 1 and die 1. So we have a 1, 1. We also could have a 1 with die 1 here could go with a 2 from die 2. So I'm just look at the pattern. So 1 could go with 3, as well as 1 could go with 4. So it's kind of obvious that you could think about it, say number 1 die. So if I have the number 1 die, for die 1, yeah, when number 1 come, it could have come with a 1, it could have come with a 2, it could have come with a 3, it could have come with a 4. And we're going to do the same for number 2. Number 2 could have come with a 1, number 2 could have come with a 2, number 2 could have come with a 3, number 2 could have come with a 4. And then you're going to start see the pattern. Number 3 from die 1 could come with number 1, from die 2, number 3 could come with a number 2, the same number 3 could come with a number 3, the number 3 could come with a number 4, and lastly, 4 could come with 1. And we are saying that 4 could come with 2, 4 could come with 3, and 4 could come with 4. Those are the 16 possibilities that can occur. And any question that they want to ask, we can respond to it from right here. So this is what you call your sample space. This is your sample space. And the sample space refers to the total possible outcome of an idea. These are the only 16 events that can occur if I throw those 2 dice out there. Is using your sample space table created in A or otherwise. So it's up to you if you want to go otherwise. Determine the probability of obtaining a 4. So it's all about a 4. First question on both. So we're talking about if I throw it down, what's the possibility to get a 4 on both? A 4. So these are 2 separate die being thrown. So we could pick it, a 4 on both. I could go to my sample space and I could tell you that we could look, a 4 on both. Here it is. We have a 4 on both, right there. So that's 1 over 16. That's 1 out of 16 tries. So we're saying that so we're saying the probability to get that is 1 out of 16. This one, we could write out the answer, 1 out of 16. So that is using the table. For the otherwise, of which otherwise just giving you alternative ways, you're thinking of 2 independent things being thrown. What's the possibility of getting a 4? It's 1 chance out of the 4. Because it's a different die that And so when we use the term and, so what we're looking at is the probability to get a 4 and another 4, two different dies. So and is when you multiply your probability, and if it is or, you will add. So it is and a 1/4, and then you're seeing that you're getting back that 1/16. So that's the alternative method. All right. Number 2 says to get a 4, remember the probability is already saying to get a 4. All right, on at least one die. Now we're thinking about getting a 4. So the probability of getting a 4 on at least 1. Now, if you're going to get a 4 on at least 1, you know what's going to happen. We have 2 different dies. So here's what happened. These ideas are slightly different in the way in which we're going to approach it. So it is on 2 different dies, at least 1. So you have a probability where you can say, listen, we can go on, let's go and count it first, and then I'll give you the alternate route. All right. So using your sample space, at least 1. So going back on our sample space, at least 1 4. So we're looking for all the places we see 4s. 1, 2, 3, 4, 5, 6, 7. Because at least 4, you know, would have been 4, at least 1 die. So we have the single dies, and then you have the double die too, because that's a case as well, at least. So we got 7. So the answer is 7 out of 16. All right. Let's see if we could work this out and get 7 out of 16. Let's try another option. So having your sample space, you could read off your 7. Hold on. You're 7 out of 16 already. Everybody see that. Just an alternate route so that you could just probably have ideas how they work. Probability, especially, oh Lord, I hate what's going on with the pen right now. So we have an alternate route. You're thinking of this. On one die, when you throw one die, you'll get a 4. But on that same die, on the other one, you'll not get a 4. So we're saying, think about what we're saying now. You're going to throw them the 2 die. On one die, you get a 4, but on the other die, not a 4. So I'm using the complement to not a 4. So that's one case. Or you could, on one die, you could get a not a 4 on the other die and get a 4 on the other die. We're talking about 2 dice being thrown. These are the things that will happen. You get a 4 and the next one says not a 4. And then it's a possibility that that other one says you not get a 4, you get a 4. That sort of thing will come out, right? So then, and then now outside of that, we will also get a case where we will end up getting, hold on, let me push this across so I can get a little bit of writing space. Or we're talking about the probability of getting a 4 on die 1 and getting a 4 on die 2. So we're talking about the possibility if you throw it, what's the probability of getting at least 1? So we're talking about 4 on this die, but when you throw down the 2 things, you know, there is something else that happened with the other die. And then you think about the other die, something else happened with the other die. Or you think about, oh, let us see we get the 4 one time. So when you think about this, the probability of getting a 4 is 1 out of 4. And for not getting a 4, for the other one, that's 0 out of 4. That's one idea happening. Or means that you plus, you not get a 4 this time. So we're switching the idea, like I'm saying, die 1, die 2. And then this, you get a 4 on the other die. That's a possibility. As well as you could have gotten a 4 on both die, and that's a possibility. We got that already. Then now we're putting this together. This is 3 over 16 plus 3 over 16 plus 1 over 16, which is 7 over 16. So you could see that these are alternate routes, but these are more difficult routes to go. I'm only showing you the possibility of what happened when you throw the dice. Just how probability works out. All right. All right. So the 7 over 16 is good from my sample space. Anyway, I would have gotten that and gone a long time. Exactly 1. Exactly 1. So if it is exactly 1, if you think about it, for exactly 1, there are only 2 possibilities. Let's go for it, the sample space first. Let's just go and get it. Exactly 1. So it's going to be 6 because we just counted. So it's going to be all of these except the double because this is 2. So we'll get 1, 2, we get 1, 2, 3, 4, 5, 6. So it's 6 over 16 and you can break that down. That's like 3 over 8 if we break it down. So that's the probability of getting at least 1. No, not at least. Exactly. Just exactly 1. All right. Exactly 1. So let us see exactly 1. We just look at the sample space and says we get 6 out of the 16. If you're going to work out this in the alternate route, or maybe the question was set and never had a sample space and you're thinking of it. So an alternate route to get that answer is that we want to think of like, okay, remember now, we're just getting 1. That means the probability will occur that, hey, I'll get a 4 on one die. That means on the other die, I will not get a 4. So I use complement. And so that's one case. So or I'll get a 4, I'll not get a 4, then I'll get a 4. So if you realize, I just alternate the idea because it's 2 different dice. So then this would have said this is 1/4. Hold on, guys. My pen. Hope it's okay by later. 1/4 with my 3/4. And I'm going to be adding that to my 3/4 times 1/4. So now we're looking at 3 over 16 plus 3 over 16, and we get 6 over 16 just the same. We could cancel them both though. We could get 3 over 8. We would have done 3 over 8 there, right? So you realize that we're still getting the same answers as long as you're taking it in the right context. Show that obtaining a 4 on both die are independent. Like they're saying that show say you can get a 4 on this die and it does not affect you getting a 4 on the other one. Like they are independent things, because you saw that there are 2 different dies anyway. All right, we normally use like 2 intersecting sets because we can get a 4 on both. So we probably want to show that, listen, you see this section that I'm about to shade here, that's going to represent when I get 4 on both. So that, but this is die 1, this is die 2. So here's the idea. I can get a 4 here. And this is die 1 only. So if I get a 4 here, I will, so a 4 there, I will not, so I will not mix with, so this is like die 1. So this is like die 1 only, die 1 only. This 4 is in die 1 only. Let me just write die 1 only. Yeah. So it's not merging with the other one. So it's like I'm saying I could get a 4 in die 1 and not die 2. Yeah. Right there. As well as I could do the same thing here. I could get a 4 in that region. This is die 2 only. Yeah, I could get it. So I could get die 2 only. So I get a 4. Yeah, 4 and die 2. And it's not You understand? Die one. So you want to just show that. That's what you're referring to. But in here, you could see where it's overlapping. That's the overlapping part, you know, where you could get from both. Both fours are both dice. I could say both dice. Let's put dice. Because I think both mean plural, right? For die. That dice. All right. So there it is. That's like showing. So this is just you understanding that you have the only part of your set where die one only, die two only, and both. So this is showing you that, hey, it's independent for real. And if you really think about it, like, yeah, it's really independent because we could really throw the dice. They don't mingle. Getting the fours don't really mingle. Determine the probability of obtaining a 4 on both die, given that 4 was obtained on at least one die. All right. So all right. Given that 4 was already obtained on one die, what is the probability of getting? All right, let me go back for it. Go back to your sample space. All right, let's see if we can understand. Determine the probability of obtaining a 4, given that 4 already occurred. You get it? On your sample space, you're going to see, look for the ones with a 4 already. All right? And then now they're saying, given that one occurring now, so we have a 4 already, so we're going to look for those possibilities, because if you don't have a 4 already, you're not in this category. So we're talking about 1 4 is already gone. We're going to look for all of that. And then now we're going to pick now where we see another 4. That means we're looking for the double 4 now as a probability of 4s. Basically, that's what they're saying. Because we're going to talk about both dies. You go to your sample space, I think that's a 1 7. Because we already saw that it's 7 times we get 4s. And there is only 1 out of that 7 times that we get 4 4. Because that's what this is saying indirectly. Because we would have seen the 4. So we have the singles, 7. We would have seen 4 at least 7 times. And then no, there's only 1 time, yeah, that we have a 4 again. So the answer is 1 7. Because what's the probability of getting a 4 on the second die when there was already a 4 already? So we said, all right, there was already, so before I saw this, so if I want to take out this, I said before I saw it, I saw 1, 2, 3, 4, 5, 6, 7. And then, oh, this is the only place that a 4 comes back. So you're like, okay, so it is this one on top, because that's the second 4 over the total possibilities, which is 7. So this is just 1 7. And I said the sample space is really crucial. Having the sample space, you're able to look just to see, and you pick and you're gone. All right. Say A. If you want to choose A, if B occurs already, like this is how they set it up. What's the probability? So they put a slash here. This is how it sets up. Like, what's the probability of choosing A if B is already gone? So this one is saying, this is how you work it out. You want to find the probability of their intersection. So the two things that we're talking about, what is the probability of their intersection, right? And you want to put that, you're going to put that now over the probability of the last one, give the one that occurs. So what is the probability of getting another B given that we have a 4 already? Another 4 given that we have a 4 already. That's what this is saying. What is that probability? So in this case, now let's think, what is our intersection, meaning what to get a 4 on both dies? We already knew that is, I think that's 116 from what we had. To get a 4 on both dies is 116. And you're going to divide that by the probability to get a 4. And that was at least a 4. That was what again? That was that 7 over 6, 7 over 16 to get a 4, don't?
Yes,
at least a 4. Because it was 7 chances. And And then you could see the 1,7 coming from this right now, though. By looking at it, we see the 1,7. Yeah. So as I said to you, given you need to note this down. I don't know if it's on the formula sheet. So it's a conditional probability where I'm saying what is the probability of getting one event given that an event gone. So all you're going to do is to find the intersection of the two concepts and then put that on top. And then you're going to divide it by the bottom one, the last one that is gone, that one that you say is gone. So when you put this together now, look how it works itself. For the top number, that is 1/16, and we want to divide this by, I'm not rushing it, by 7/16. And then you work out fractions. You will now reciprocate. So now you see the 16 on top of the 7. And hence you're seeing where the answer is still 1/7. All I'll say to you, I don't think I'm interested in these workouts. If my sample space is available, I'm not interested in working them out when I could just look on the sample space and pick them. And based on what I've seen, they will always give you that opportunity to pick from your sample space. So the fact that whenever you make a sample space, you have all the things looking at, I think you have a great shot at it right there. But these